Hello friends, so today's video we will create a weather classification model from scratch, means the CNN model from scratch. So let's get started. Before that, let me download this Roverflow library because it's required to download a dataset from the Roverflow. This is a dataset which we will download it in the folder. Okay, let me download the dataset. It will take time, and the folder name which the folder name from the Roverflow will be the weather one. Okay, but I want to change the name of the folder name. You can see this to the weather classification data set. So how we can do that? It's very simple. If os.path.exit old name means the weather one is exit, and this new name is not exit, then we have to rename it. Otherwise it will just show this message. It's required because whenever it might be possible that I have to run all cell again and again, so it will throw me error at that time. So that's why these are the libraries which we required: pandas, pd, torch, and this. And main thing is this one. If torch.coda is available, if you want we want to know that whether we have a cpu or a gpu for the training purpose. So this line give us the value that whether we have a CUDA or a CPU. If it is CUDA, then the device, we can say this device variable have a CUDA, otherwise it's have a CPU. Okay, and its importance is that it might that a training labels, images, all thing has to be on a same device, whether it is a CUDA or a CPU. Okay, this is a train directory. Let me show you. Is a train directory which we have, and the number of classes which we have for the train for the weather classification is cloudy, rain, shine, and sunrise. Okay, now we have to create a dataset class. The importance of creating a dataset class is just that it return the you can say the images and label in the PyTorch format, which is used by the data loader for the training purpose. Okay, so let's get started. The class name will be image folder dataset. Dataset basically is you can say the class inheritance class. Then we have to initialize everything. So how we can do that? It's very simple. First we have to create the def init function, then the self, then root directory basically you can say it's a train directory only. And transformation is you can say if you want to change the you can say that if you want to apply the data augmentation in the to the images, so these are the transformation, but initially it will be none. Okay, then we have to initialize root directory, then a transformation to transformation. And now we have to means how many number of classes which we have, a classes folder we want to know. So when you will do the os.list directory, it give me the list of all the folder name inside that particular directory. Okay, let me show you. It give me this cloudy, rain, shine, and sunshine in a list format, in a sorted format. Okay, after that I have to link this with the class id. So how we can do that so if suppose the self dot classes have this rain, sunrise, and cloudy list, and when I will use this line, when I will use this line for IDS class in enumerate self dot classes, it basically class here, and after that it will class means it will link the class id with the means class name with the class id. So how it is: 0 for the rain, 1 for the sunrise, and 2 for the cloudy. This way it will link it. If I will use this line here, okay, it will make a basically it make a dictionary here. Okay, now after that it's after making this dictionary which link the class name with the class id, we will make a sample that how many empty list will be there, which is just store the image path and the label. Whenever we use the data loader or train this, it will just pass the image path and the label in a pair format. After that, loop through the each class. What is the use of this means basically it make a list of all the image path with the label. How it we can do that? Just you have to self classes, loop over the self classes, means you can say class name, folder name. After that I have to create a complete folder name, folder path, sorry. So how we can do that is just use os.path.join, then the root directory and a class. This way we'll get a complete folder name. And if it is directory is exit, it will if it not exit, it will continue. Otherwise it will go to this for loop. Inside it we will make up all the uh, here this os.list directory class folder name, Using this line, we will make a list of all the images path name inside it in the current, we can say current folder name. Okay, current folder. We will make a list of all the images images path inside it. After that, we iterate over it. After that, we will open that. We can make a complete image path. How we can make a complete image path? Just use this class folder where the path dot join class folder and the image name. We will make a complete image path. After that, getting a complete image path, we will append that image path. Means we make a first pair. As you can see, we will make a pair, and we are making a pair with image path and a label. And how making and label, basically you can see the class id. So how we can get a class id? Just use the class dot idx which we have used, which I have created here. It will give me, when you will pass a class name, means the class name, you will get a class id. So this way you will make a pair. And when you will append this in a sample list, it basically create the list with the pair of image path with the label. Okay, and this will turn to each folder name. Okay, so this way we get a sample. After that, we will make one, you can say the length function. Here, just when you pass the self dot length, it will give me the list of names completely how many number of images which we have. Okay, it give me that thing. After that, get item basically return the image with the label. How we can do it? And image we are passing, not an image path. So how we can do that? How we can get an image path and how we read that image? So it's up to here. Means get a single image and by the index. How we can do that? First of all, using the idx which we have, self.sample idx, we will retrieve two things. You already know that when you use this ideas, we will get a pair thing. This is this two pair thing. We will get it, image path and the class id. So we will get the image path and a class id. After that, we will using this image path, we will open that image. And one more thing that I have said you, that transformation is a data augmentation which we apply, or sometimes we have to resize the image. At that purpose, we will use the transformation, or we have sometimes we have to you can say convert the image or labels into tensor format. So that's why it's required. So if any transformation is required to the images, we will apply the transformation. After that, we will return the image and the label. So this way we will create a you can say the image folder dataset class. Okay, which we require to return the image and label in the tensor format, or you can say into the format which is required during the training. Now we have to plot the graph that how many number of images is present for the cloudy, rainy and shiny in a train directory. So how we can do that? Just very simple it is. So we will list of all the images folder name inside the train directory. Using this, you already know what is a variable train directory basically hold. Here it is a train directory. Okay, now, after that, when we will list of all the list of all the folder name inside a train directory, we will iterate over it one by one. After that, when we will make a folder path, complete folder for how we can do that. Just use the train directory and the folder, and use the path. Then you will get a complete, you can say the complete folder path. After that, if os the path or is directory, if path directory is exit, it will be if it is exit only, if we will move to the inside the if loop. Okay, then we will make a make first of all we will make a list of all the images present in that particular folder class name. After that, using this length function, we will get to know that how many number of images is present for that particular class name folder. After that, we will pass that to the count dictionary which we have created here. You can say this is an empty dictionary. Okay, we will pass it with the folder name and the image count. Basically, folder name will act as a class name, and image count give me the length of the images present for that particular class name. After that, as you can see that we will first make a classes list. How we can make a classes list? Means the class names. It's very simple. Count dot dictionary and the keys give me the class names, and count as dictionary dot values give me the list of all the counts. Okay, now it's very simple to plot the bar graph. How? It's very simple. Plot the figure size will be 12 by 16. The plot the bar we have to plot for the classes x label and count for the y, and x label, y label, title. It's very simple. What's the meaning of that? X tape mean rotation, 90% rotation, tight layout, and show. Let me show you now result of that. So it's very easy. You can see this cloudy, 600 more than 600, and 700 more than, I think the exact 700 for the sunrise, rain. So mostly we have number of images most have for the sunrise. Okay, now, and this is you can see the result of that dictionary which we have created. So let me show you. Let me see this. Cloud is 620, sunrise 700, rain 44, and sign 534. Okay, now let's get started. Now we have to create the dataset, or you can say the data loader. How we can do that? First of all, yeah, let me explain you this thing. This is a transformation which we have to apply on our images. Okay, so for that purpose, we first use a transformation dot compose, then this function bracket, then the list, that all things which we have to apply. So here, list is basically give the things that which we have to apply on the images. First of all, we have to resize it to 60 by 60 pixel. After that, we have to convert it into two tensor. Basically, converted to tensor, it means scale label value to 0 to 1 range. Okay, and one more thing, that two tensor basically convert the dimension from HWC to CHW form of the images. Okay, now then after that we have to normalize the pixels value. So how we can do that? Just for the purpose, we have to use transformation dot normalize, then the mean and standard. And why we have a list of all these three values where we are passing it? Because because each image have RGB channels, so that's why that is required, that for the mean R channel for this, R channel B, and this for the B channel. So this way three values has to be passed for the mean and standard. After that, it will give me the normalized pixels values. So this is other transformation which we apply to the images, okay, during training, or we can say. And then this is, we can see that train dataset is the object of the class which we have created. And when we create the object, we have to pass the variables also. So first of all, we have to pass the root directory, then a transformation which we have to apply on the images. Now we have to create data loader, which is useful for training. Okay, it's very useful. For here we have to pass a train dataset, the object. Then batch size 32. What is the use of batch size 32? It means that when you will divide the images into batches, then each batch have 32 images. Shuffle true, yes, we have to want to shuffle. Number of worker, what is the number of workers? Number of workers, thread for loading data, parallel loading. And speed optimization, faster transfer of data to GP if using CUDA means pin memory will be true. Okay, so train loader. So we have to we have created train loader. So let me run it now. Now we have to get the length. See, now when you will use this transformation to the images and want to know the shape of the images, when you have to use this data loader. So first of all, we have to use a train dataset dot get item. Zero index, you already know that in a class which we have created. To call this function, we have to pass one variable idx, may the index value, which will give me the image path when you will use a get sample. Okay, self dot samples. Okay, so when you will pass a zero index value, and when you will use a zero dot shape, it give me the torch dot size, that means the dimension. You can say this is a CHW format. And when you will give try to get the length of the train loader, basically what is a 73 is basically the number of batches which we have, and each batch has 32 images. Okay, now we have to plot the images just for the purpose that you can say the labels and the plot labels to particular image is correct or not. Okay, so how we can do that? Just very simple it is. First of all, we have to make the iterator of the train loader. Then we have to use a next function which give me the samples and labels. Okay, what is the samples and labels? Here is samples and label basically store the information of 32 images and labels. Now we have to plot the 16 images. So how we can plot the 16 images? For that purpose, we use plot.subplots, 4 rows and 4 columns. Means here 4 rows and 4 columns. Then the figure size will be 20 by 16. And basically here figure basically represent the entire subplot, and axis basically used for the iteration. But here in list line it is in 2D format, but when you will use access dot variable, here it will be, it convert to 1D format. And classes name which we have is cloudy, rain, shine and sunrise. Okay, so this way we get the class names. Okay, cloudy, rain, shine and sunrise. Okay. Okay, so for the protection for the 16 images, we have to loop the for loop for the 16 time. And you can see this is the class names. Okay, we have to use the class name. So basically labels, you know that in a get item, you can say in this get item function, when you will pass the idx, you will pass the you will get the image and a label in a class id format, not a class name. So how we can get a class name here? Just very simple it is. Then use the label I, and dot item give you the class id, and when you will use this class id, it will give me the class name. Okay, after that, and after getting the class label, we have to show that image. And one more thing that very important, it is that we are using the permute 1 to 0. What is the use of this permute 1 to use 1 to 0? When you will use the sample I. Okay, so it's very simple it is, because when we use a two tensor in a transformation, which I have explained you here in two tensor, basically it convert the dimension of the image from HWC from to CHW. but for the plotation of the images we require the same dimension. So how we can do that? For that purpose we use the permit here, which convert the dimension from CSW to SWC, and after that we set the title label. Now let me run it. Let me, and when you will see that this is a highly contrasted images here, because these are the normal, you can say normalized images is it. Okay, and you can say blurry images because the size is 60 by 60. Okay, sunrise perfect, shine perfect, cloudy perfect, rain perfect. Okay, so the labels and the images are perfectly aligned, so there is no problem in the data loader. Now we have to create the CNN model from scratch. So let's get started. It is, so first of all I want to tell you that we have a three convolution layer. With each convolution layer have a Maxwell layer and three fully connected layer with flattened layer. So let's get started. Now, first of all, to create a CNN model from scratch, we have to use CNN. You can see the class name, then an and all module. Okay. Now we have to first to here this in this particular. Let me explain you. In this is init function. Here we are just defining the images that which class you can say which layer we want to use in the CNN model from scratch. But here here we are just connecting them. Okay, we are connecting them from connecting the layers here, but here just we are just defining them. Okay, so let's get started. So the block one means the number of image you can say this is, you can say the super class which we have created, which we have called here CNN super class. Okay, so here we call a superclass CNN superclass within constructor. Now this is input. Now we got to know that we have to convert using a transformation. We have to convert the image size from 60 by 60. So this is the input format of the image which we pass to the first layer. Okay. Now here you can see this is here are three variables here. There are three, basically here three first three. This three is a, you can say the input channel, and 16 basically the output channel, and 3 basically here the size of the kernel size. Okay, so let's get started. Let me show you some images here for better explanation. So here this complete background, this background is basically the input image 021410 e. You can see the kernel size. Okay, and when you will move this kernel size to over it, you have to do some calculation here and you will get this result 16. So this is a use of this is a convolutional and the kernel size and how the calculation is performing. It's very easy and you can see this. Now go back to here. This is a formula for calculating the, you can say the, for calculating the you can say the size of the dimension of the output dimension of the first layer. Okay, so how we can calculate it? First of all, let me explain you here. W is, you can say the you can see the HW, or you can say width, height or width, but here 60 is same, so it means height and width remain the same. So here W is basically here initially it will be 60, and F will be the, you can say the kernel size. Here filter, you can say F for the filter, but you can call it filter also, kernel or kernel also. So for F will be you can say the kernel size. 2p, what is p here is, you can see the padding, and let me show you. This is the padding. When you apply padding 1 here, you will get this 00 around the image. Okay, but convolutional, you can say, let me show you one more thing, that what is it is convolutional, huh? Okay, in convolutional you can say padding default value will be 0, as you can see it here. Default value is 0 and stride default value will be 1. And what is use of a stride is that stride is this thing. Okay, let me show you. When you will use stride 1 means initially when stride value will not get changed. The calculation which we are performing here, let me show you the calculation which we are performing here, this movement here. So this movement this movement will be like this. There is no gapping here. When you will use stride 2, it will it will gap 1 here. It will skip this line, this skip this row here. Here the skipping of the row will not perform, but here skipping of the row is performed. So this is use of stride and padding here. But and let me explain you. So in padding, basically in convolutional 2, padding value will be 1 and padding value will be 0, and stride value will be 1 as a default. So when you will do some calculation here, you will get the output dimension of this first convolutional layer. So how 60, you can say W is 60, which is fixed. F means kernel size, which we have performed, which we have applied here, 3. Okay, and 0 already know, because padding value in default value for padding for the convolutional layers will be 0 until unless you define it. Okay, then you will divide with 1, means the stride already 1. When you divide it 1, 60 plus 60 minus 3 means 57, plus 1 will be get the 58. So dimension of this layer will be, output dimension will be 16, 58, 58, and there's 3. How we can get a 3 here? Because inputs, image channel means RGB channel will be 3, that's why it's have a 3 input channel. Okay. Oh, where it is gone? Okay. Okay, so here it is. Now you will get its dimension when you will do some calculation, 16, 58, 58, and 16 basically your output channel. Basically 16 output channel from the conventional layer act as the input channel for the next layer, and the next layer is a max pooling layer. And one more thing I want to tell you, in max pooling layer, you can see this in max pooling. In max pooling layer, stride value will automatically equal to the kernel size which we have to define. And here we are just passing the kernel size here too. So stride value will be 2 here. So, and what is use of max pooling? And let me explain you. Oh, where it is gone? Max pooling. So when you will do some calculation with the max pooling with the kernel size 2 by 2. So max pooling, you will go to here, this area, rad area, and when you max pooling basically tell me the which is the you can say largest value or a biggest value or a greatest value, maximum value. Here it is a 20, so it give me 20. Here in yellow region 30 is the maximum value, and here it is a 112 is the maximum value, and here in green region 37 will be the maximum value. So this is a use of the max pooling layer. Okay, so let me come back. Here too, basically passing the kernel size here, and if we passing the kernel size 2, the stride value automatically get to 2 until and unless we define it. Okay, so when you will do 58 minus 2, you can say where it is come for 2, because padding value always will be 0. Okay, so when you will do minus 2, and minus 2 come from the kernel size which we have defined, and 2 his stride value will get 2, because the kernel size and stride value will be in the same. So when do this some calculation, you will get a 29 here. Okay, now we have to move to the third layer. The third layer which we have is, you can say, the this layer same. Here 16 will act as a, you can say, same has a input channel, means the input channel, and 32 we is the output channel, and 3 we can see the kernel size. So after that we will do some calculation. The output dimension will be 32 27 into 27, and same way for the max pooling here. Okay, same way for the convolutional, and same way for the max pooling. So everything is same here. We are passing the 3 convolutional layer and 3 max pooling layer connected to each convolutional layer. Okay, now we have to move to the flattened layer. Here we giving the flattened layer here. So here we create a flattened layer. So what is the use of for getting the flattened layer? We use and at flatten. And I think I have forgot to explain one more thing, that the import libraries, the libraries which we want to import for creating the CNN model from scratch. These two layers, these two imports are important. Okay, torch.nn and torch.nn functional has f. Okay, so these are the important libraries which we require for creating the CNN model from scratch. After getting the 3 convolution layer with each max pooling layer connection, we will make a flattened layer. So this is a use of the flattened layer. So when you will do this is after convolutional layer and max pooling layer, when you will use the flattened layer, this all neurons converted to this 1D format. Okay, and the number of neurons will be equal to this 64 5 into 5 into 5. You will get a 600 number of neurons in 1D format. And now we have to apply the linear layer, or you can say the fully connected layer. What is the meaning of the fully connected layer? You can say this. After the flattening layer, this you can see the first layer of fully connected layer. Fully connected layer means each neuron from the flattened layer will be connected to the next fully connected layer. Okay, each neuron connected to each things. As you can see, this is a neuron. It's connected to each number of neuron from the flattened layer, and same before the second, same before the third. So that's why it's called a fully connected layer. Okay, so here is a, you can see the input. input channel will be 64 into 5 into 5, okay, after the flattened. And output channel is decided by us, it will be 256. And next fully connected layer, it will be 256 and 128 output channel. And the last layer, output channel is according to us, according to our number of classes. So number of classes which we have for the, you can say, we have a 4, so output channel, output number of neurons will be 4 for the last fully connected layer. Here we are just defining the number of, you can say, the layers which we want to we want to use. Now in forward we will define it. Here X basically act as an image. Okay, now first we have to connect the, you can say, oh, it's very complicated for you, but I will make it for simple for you. Okay, so this way, this thing is remain the, this is the first thing which we will use. F dot relu self dot convolutional one. This is the first thing which we connect X. After that we will connect the pooling layer. So this is the convolutional one, this is a pool one, this is a convolutional one. Let me show you one simple example how it's working. F is equal to means self dot con1 x. Okay, so this is the things which is happening here. Okay, but I just combine all three into one, so don't get confused. Then we have to apply the ReLU function. So how we have to apply? For ReLU we have to use f dot ReLU, and then we have to pass the x here. Then we have to connect the max pooling layer, because after every conventional layer max pooling layer is here, so we have to connect that also. So self dot pool one, and then we have to pass it just x here. Okay, here pool one and conventional one is like is this thing. Okay, pool one, pool three, which we have, which is the, this is the variables lane or layer name which is decided by us. Okay, okay, so that's why this whole three things, is in this one complete line. Okay, so this way we are doing the connection here. And now let me explain you what is the use of this ReLU here. So the use of this ReLU is this thing. Okay, ReLU activation function. Rule of ReLU is that whenever the value is less than 0, it's going to be converted to 0. And if the value is greater than 0, then the value remain the same. As you can say, 101, 27, 61, 250 remain the same, but all the value which is less than 0 is converted to 0. So this is a ReLU activation function. Now go to here. Okay, I hope you understand how the connection is going on in this line. Okay, and now same way for this second layer, same way for the third conventional layer. So let me erase it. Okay, or let me make it comment. Now after that, you already know that after using the three conventional layer, we have to flatten the layer. So for the flatten layer, we just used to use self dot flatten and just x here. Okay, now after that we have to connect the fully connected layer. So how we are using the fully connected layer with ReLU activation function? Just use the self dot ReLU in an activation function in a f dot ReLU here. Okay, and same way for the second fully connected layer. Now the third, for the third fully connected layer, we have to just pass the image, and you will get a number of neurons, 4 neurons with the activation with the values with inside them. Okay, now let me run it. Now it's one more thing we have to apply here. We have to make the variable of the CNN class which we have created. Okay, now here one more thing, model is equal to model dot to device. Here we are passing the model to the device which we have. Okay, now everything is okay. Now let me run it again. See, you will get the everything result here. Combination layer, kernel size, layers, and the dilation. Now we want to get the summary. So how we can go do that? Just it's very simple. As you can see, this you can see the dimension here. These are parameters. So the total number of parameters for this which we have is 468,916. Okay. I hope you can understand what is happening here. Now This is the, you can see the criteria optimism which we have to define here. So the cross entropy loss we are using for the loss calculation, because the number of classes which we have is greater than one. And we have a optimizer. The optimizer which we using is Adam, and these are the parameters which is trainable, and learning rate, initial learning rate value will be 0.00006. Okay, this is optimizer which is used for the updation of the weights values, and criterion basically used for the calculation of the loss which is required during the trading, because according to that only we have to update the weights value, the gradients values. Initially I want to just train it for the 5 epoch, because I already have a model which is trained on 50 epoch. If the training after training of 5 epoch, if the you can say the testing is not good, I will upload the model which is trained on 50 epoch and show you the result of that. So don't worry. Now let me run it. Here we are doing the trading, so it's very simple. So TQDM we just use give the visualization clearly. TQDM we just to get the visualization very good, and it give me the bar here. Initially the train loss and train accuracy it's empty, and we are defining it just to create the graph after the trading, and it basically store the train accuracy and loss for each epoch. Okay, now we have to iterate according to number of epochs which we have. For that purpose, we use for loop. And one more thing, for each epoch, has model has to be in a train mode, not in a, you can say the not in a evaluation mode, because first and here we are doing a training, so model has to be in a train mode. Correct is zero. Initial number of correct prediction will be zero. So we have to calculate the, for each epoch we have to calculate the how many number of correct prediction is made by the model. For that purpose initially it is zero for each epoch we are doing. So after inside the for loop of epoch only we have to use the correct is equal to zero. Running loss and total sample. Running loss basically give me the loss for each epoch, and initially it will be 0 0. Total sample it give me number of in each epoch how many number of sample or how number of images used for the training purpose. Now here it is a TQDM, we are defining it here. Just pass a train loader which we have created, the message which we want to display. Leave true. What is user the leave true bees keep progress bars after completion. Okay, so that's where now we have get a progress bar. Now we have to iterate over the progress graph. For each iteration, it means we are iterating over the batches. For each iteration, data and labels basically store the information for 32 images. Okay, now everything I want to everything we have to pass to the device where on a whether it's on which the model is it is. Okay, so how we can do that? We have to just use to device non blocking true, non blocking true. Okay, and why we are doing it? Because if the labels and data and the model is not on a same device, then it will throw error during training. Okay, so it's very important. And now optimizer zero grade. What is use of this optimizer zero grade? It's very simple that optimizer basically make gradient value for each batch iteration, make the gradient value zero. Why? Because if the gradient value will not become to zero, then it will accumulate to next iteration batch gradient value, and it will disturb the training. Okay, and the training and the weight will not get updated properly. So that's my purpose. Optimizer zero grade will make the gradient value to zero for each batched iteration. Listen me clear that I'm talking about for each batch iteration, not each epoch iteration. For each batch iteration, gradient values, or you can say the weight value, becomes zero uh, for each batch iteration using the optimizer. After that, we'll be just pass the data. Basically, data store the images uh, of 32 images. Okay, so we pass the images here. Output will be means the prediction for each image, for each 32 images. Okay, now this is criterion. It's throwing me error. Let me show you. Let me copy this and paste it here. Now we have to calculate the loss. For that purpose, you use the criterion here. We just have to pass the output, the prediction made by the model, and the labels which we have, original label which we have. It will calculate the loss. After calculating the loss, we have to use the loss dot backward. Loss dot backward basically, here that we have make the gradient value 0 after this model pass and prediction made by the this. Loss dot backward basically calculate the gradient value. Let me listen me clear that I am talking that here the gradient value calculation is performing, not updation is performing. When we use optimizer dot steps, updation of the weights value will get here. Hope you understand clearly. Now, what is the use of this running loss? Running loss, which we have explained you, which is store the you can say each epoch loss, total loss. So for that purpose, we have to store each batch loss. So for that purpose, we use loss dot item, which we accumulated in running loss variable. After that, we have to get the prediction made by the model. Suppose you can say suppose we have a batch size 2 here. We have a batch size 2 for 3 classes. Okay, suppose we have a batch size 2 and we have a 3 classes only. So when you will so the output made by the model will look like this for the sample 1 and sample 2, because we have only 2 batches and 3 classes, so it will look like this here. Okay, it output will look like this. And when I will use this argument max dimension 1, it give me that sample 1. It's for each row argument dimension 1, pick the index of the highest value. So 0.7 will be this and 0.8 for the sample 2. And after that, output dot argument dimension 1 give me the prediction like this. Okay, it give me the list of the prediction made for the each sample. Okay, after that, we have to find out how many correct prediction is made by the model for each batch, each 32 batch images. So for that purpose, we have to pass the prediction and the labels both. Then sum dot item give me the correct prediction made by the model for each batch. After that, we have to find a total sample. Label dot guide give me the total sample for how many number of images present for each batch. Okay, so this way whole thing is happening for the batch iteration. Hope you understand something here. Okay, after that, after coming from the for loop for the batch iteration, we come to the epoch iteration for loop. In this we have to calculate the epoch loss. So then when you pass the running loss divided by total loss, total sample, you will get the epoch loss. How we can calculate the epoch KC? Just 100 minus correct prediction made by the model, total sample, you will get the epoch, you can say the epoch accuracy. We have to append that to train loss or train accuracy just for the plotation of the graph. Then we have to display the masses here. Now let me run it. Just here with training will going on for the training will get started for the you can say the for 5 iteration, 5 epoch. Now we have to plot the graph. So how? It's very simple to plot the graph. Epoch log range, we have to first create the range according to number of epoch value which we have. Then for the plotation for the first graph, we use figure.xs to plot the subplots. Here we pass the x value, epoch log, train loss will be the y value, red, yes, it will be red, straight line, not dash line, label will be train loss. X label, Y label, title, listen, show, everything remain the same. And in train accuracy, we pass the epoch log remain the same because here we just 0, 1 to 30. And then train accuracy. B means blue with dash value. Here we it's this line will be displayed with blue color. Here this line will display with red color. So this way there is you can say, oh, training gets completed for the 5 epoch. Let me show the result of that. Oh, it's very, I think so it's working very well. Train loss going down and train accuracy is going up. So our CN model is pretty good. Okay, now how to save the model? For saving the model, we use path weather.pth, the torch.save model.stake date, and then path. It will save the model. Now let me run it and let me show you that our model is saved here. Oh, this is Google. It's an extra cell. Don't require. Now we have to load the model. So loading the model, we have to use model.load state.dict toss.load. What we have to load model. So this is weather.pth, the path. Then the map location will be device. After that, it's very easy. Model to device. Then the evaluation model is now have to be in evaluation mode. What is the use of evaluation mode? That there is no updation of the gradients will be performed. Okay, so let me run it now. Now we have to do the plot the images, or you can see the testing of the images has to be performed. So what's very simple. First of all, we have to define a directory. Then when we use os.list directory, test directory, it'll give me the list of all the folder names, not the images, all the folder name, or you can say the class name present in that particular directory. Now pre-processing. This is a function which is required. What is use of the pre-processing function? Let me explain you. This is, you can say, important thing that what is the input size of the images during the training, what is the format of the images, whether it's in a tensor format, into format, everything, and what is it is in a batch side routing or not. So this thing, the means all the transformation which you have applied during training has to be there during testing also. I'm not talking about not talking about this increasing the brightness, increasing contrast. This these are the dot augmentation. I know these are the transformation also. I know, but the main transformation I want to know. I'm talking about like resize, converted to tensor, and this thing is required during testing also. So that purpose we pass the transformation to images, transformation here, because you can say image, you can say what is a variable value. Let me explain you, which we have defined above. As you can see here, it will apply the transformation, all the transformation which we have applied before training is it will apply during testing also. So this is the value where use of it here. We are using it. It will convert that image into 60 by 60 and also convert that into the CSW format. Now unsqueeze. What is use of unsqueeze here? You can see that here we are during training, during let where it is. Here we are passing the images in a batch dimension. Let me we have a the dimension will be like this. 32 means batch dimension. Then the channel will come 3, then the 60 by 60. So this will be the dimension of the dimension of the data which is passed during the testing here. Okay, so 332 basically you can say the batch size, but when you have to during testing also we have to pass the dimension. So here B will be the batch size, will become 1 here. Okay, C channel 33 and HW will be 60 by 60. When you will do image.nsqueeze, basically it will add one dimension 1 here. Okay, and after that it will pass return the image. So this is the process which we have to apply to the images. Now for the protection section images, this two line you already know, and we have to know the class names. You have to use just train dataset.classes, you will get the class names. Now for the protection of the four images, oh sorry, we are not plotting the first 16 images, we are plotting the four images only. So for one row, four column, it's required. Now it will first from test folder it will randomly select the folder name, randomly select the folder name from the test directory. After that it will make it will make the complete folder path using this dot path dot join text directory in the folder path. After that it will make the list of all the images present inside that particular folder. Now we have to create a complete image path. How we will get the complete image path? We have to use this test directory and then the folder which we have selected randomly, and randomly select the image path inside that particular folder name directory. So this will be get a complete image path. We will open that image. Now we have to apply the pre-processing over the images. After applying the pre-processing over the images, we have to just pass the pre-processed images to the model. We get the output. You already know how the output is come out. I have explained you here better in a better way that how the images output will be there. And what is used as argument max output dot item, give me the, you can see the prediction of particular image. After getting the prediction for the particular image, we use the class names dot prediction to get the class name, I mean the label. Then directly we will show the image and the set title. Now let me run it. Let me show the result on the model which is trained just 5 epoch. Cloudy, I think so it is rainy. It's cloudy, rainy. No, it's cloudy. Oh, it's not working very well. Now let me show you the result of the model which is trained on the 50 epoch. Let me upload the model which is trained on 50 epoch. Then I will show the result of that. Okay. I think there is a problem in uploading the model .pth which we have trained on 50 epoch. So let me train it for 10 epoch. It's better for that. Okay, then we will see the result of the model which is trained on tiny block. Okay, so let me come back when the training gets completed, and then then I will show the result of the model which is trained on tiny block. Okay, so let me show you the result of the model which is trained on tiny block. I hope it will work very well. So this is how you can see the graph after for the tiny block. Now we have saved the model, we have also load the model. Now we are plotting the 16 images. So let me show the result of that, the model which is trained on tiny block. And the model which I have Train on 50 epoch. I think there is a problem inside that. Rain, cloudy, shinier. It should be shinier, cloudy, sunrise, cloudy, perfect, sign, sunrise, cloudy. So it's working very well. Okay. I hope you had gained something from it and gain some knowledge from it. If you gain something, some knowledge from from my explanation, so please like, share, and subscribe my channel. Thanks to all.